Apart from these two, PSR and SSR type of radars, there are several other applications of radar too. What are these applications? We are going to list them one by one. First, we will list these applications of the radar, and then we will move to the next type of device, that is called as the pyroelectric thermometers. So the thermometers nowadays very common, very familiar, because these thermometers can measure temperatures of human body without touching a human. So what happens in that particular type of devices? Apart from that, there are several other devices which are using this principle of pyroelectric thermometers. What are the materials, what are the principles, applications, etc. This is the second topic we are going to discuss one by one after this. Okay, so yesterday we started other applications of radar. We have mentioned in weather conditions, determination of weather conditions, like IMD, or IMD uses several such type of radars for determination of several weather conditions. Then position of mountains, that is called as the IRS, that is the different types of satellites are used to identify positions of different geographical structures like mountains and rivers, and all these things they can be detected and they can be photographed, etc., with the help of this type of radars. Then iceberg in a sea, as I said yesterday, the ship like Titanic collided with such type of iceberg because it was not known what size of that particular iceberg is, and because of that human error or mistake, there was a collision between that Titanic and this type of iceberg. Nowadays ships are equipped with such radars which can very easily identify the size of the such type of iceberg, and safe passage can be created, and therefore no such accident may happen there. Then shorelines, there are different types of shorelines available around this sea or ocean or rivers and etc. So correct mapping of these shorelines is also possible. Then the identification of different buried materials, metals, then ores, etc., that is also possible with the help of these type of radars and the technology available here. There is one more in oil industry. So oil and coal industry, COAL, okay, coal industry. This radar has several applications. These are to be named to be few, and as I said, on airport, or that is called as air traffic controller, air traffic controller, air traffic control, that is called as ATC. Okay, and then we find there is a large application of this radar technology in this ATC, that is to be understood very well. Okay, now let's list some of the important application. That is civilian use. Civilian use, that means it is used at different locations by civilians. So that is what I call air traffic control radar. Air traffic control radar. I think you might have heard about this earlier. In the airspace of India or any of the country, if I take an example of India, you are not allowed to fly any object, maybe helicopter or maybe any other type of aeroplane, etc., unless you take permission of this air traffic control authority. So there is one national authority which controls our sky, and there is a continuous surveillance of our airspace, and here only the aeroplanes or the helicopters or such other types of objects which do have a legal permission from the government, these objects are, or these particular types of aeroplanes or this type of helicopters are allowed to fly in the Indian continent or Indian airspace. And anything unidentified object comes from any of the enemy nation or any of the nation, maybe by accident or maybe by some other chance. So such type of objects or devices are very easily identified, and if they do not give any response to the signals sent by the radar or the air traffic controller of India, then such type of objects may be punished, or maybe sometimes such type of things might have happened. So this entire operation of this air traffic control is possible, or management of this air traffic on any airport is possible with the help of this air traffic control radar. So that is one of the very important application one must understand. Then one more thing is that whenever there is a large cloud or where there is a huge fog is there, it may be not possible for any other person to look at the this particular airplane, and it may be a problem in communication if you use visible devices. Visible spectrum is used for communication purpose. Then in case of fog, thick fog, it may be not possible to identify such type of objects, but radar doesn't make any problem. Whatever may be the weather conditions, whether there be a fog, there may be a dust or whatever pollution, etc., radar operations can be very useful and clear, and it is very accurate, and therefore there is no problem of that. Means even though you are not looking at the airplane because of the fog, but the radar looks at that particular aeroplane and gives instructions regarding its landing or takeoff and like that, and therefore this operation of air traffic control or operation of the airport is, I think you might have seen, there are very less number of accidents that is actually happened. In 10 years, in 20 years, 1 or 2 such type of accident happens, and this type of accuracy is because of this type of radar techniques which are used in the civilian cases. Okay. Then second important application we must understand that it has several military uses, military or defense applications.
सर माइक म्यूट आहे तुमचा.
असं कसं होईल? काही वेळ नॉट पॉसिबल. तुझ्या सिस्टीम मध्येच नेहमी काहीतरी प्रॉब्लेम आहे बरं पांढरे. नो वन इज.
आवाज येत नाही.
तुला आवाज येत नाही, मला व्यवस्थित आवाज येतो. आणखी कोणाची काही कंप्लेंट आहे का आवाजाची?
No sir, येते क्लिअर आवाज.
सो इट इज द प्रॉब्लेम ऑफ युअर सिस्टीम. तुझं जर कनेक्शन आहे, that connection is weak, and because of that you are not getting sound. Almost all people are getting my sound and you are the only. बऱ्याच वेळा तिचीच कंप्लेंट असते एकट्याची की मला आवाज ऐकू येत नाही. तर हा प्रॉब्लेम तुझ्या सिस्टीमचा आहे, माझ्या सिस्टीमचा काही प्रॉब्लेम नाही. आय एम गेटिंग, म्हणजे कुणी जरी विद्यार्थी बोलला तरी मला खूप लगेच आवाज येतोय. तुझा पण मला आवाज येतोय आणि माझा
आवाज येत नाही.
हा काय बोल ना स्वप्नील, मला तुझा व्यवस्थित आवाज येतोय आणि माझाच आवाज कसं काय येत नाही तुला? असं कसं काय होऊ शकतं? हॅलो, आणखी कोणी बोलतोय का? दीक्षा, विवेक, माझा आवाज तुम्हाला सगळ्यांना व्यवस्थित ऐकू येतोय ना?
हो सर.
हा, ते स्वप्नीलला कोणीतरी सांगा की त्याचाच प्रॉब्लेम आहे आणि नेहमी त्याला हा प्रॉब्लेम येतो. आय डोंट नो वाय. ठीक आहे, आपण जाऊया पुढच्या याच्यामध्ये. So this military or defense we have already seen. So in defense, these type of radars are generally used for detecting the enemy aircrafts, as well as we have to identify our own aircrafts, and therefore all these operations at the time of war or daily operations of all these type of aeroplanes and devices, missiles, etc., that is possible for this by this military radar. So radars widely used in military, and that's what one of the very important application of all these radars other than this civilian. Now all other details you can get on other websites or that Wikipedia too, how radars are used in for defense purpose, etc. We don't want to go into details of that. There can be hundreds of applications of radar in military itself. We are not needed to go into details of that, but understand that this radar plays a very vital role in the defense sector. Third important application of this radar is scientific uses. Scientific uses. Okay, now what are these uses? So in scientific uses, in the meteorology or meteorology, meteorology, or that is climate science. You might have seen IMD or Indian Meteorological Department that gives you the correct information of the weather conditions throughout country, region wise, then area wise, state wise, and all other parameters can be seen there. We get a very good picture of the clouds over the Indian subcontinent, where the clouds are, that what is the movement of air, what is the temperature at different locations, what will be the temperature, this weather conditions after 3 days, 4 days, 5 days. Then long term such type of effect, long term such type of predictions are also done. So all these things are possible with the help of this type of radars which are used in meteorology for determining different types of climate conditions. So again, different aspect has different types of applications, so listing them is only possible at this stage. We are not able to go into details of all that. So movements of animals, birds, insects, etc., all these type of operations which comes under this Indian Meteorological Department, or there are several state agencies, private companies too there, which give this type of information time to time, and this is possible with the help of the radars which are used in this case again. So that is what one of the important application. Then another application, fourth application, is remote sensing. So what is this remote sensing? I think you might have heard this Indian IRS satellites. Now what these satellites do? These satellites picturize actual geographical features of any region or nation or whatever state or whatever unit you may take. So how it is possible? In this case, photo images or the images taken by the optical radiations are not that good, because of the several of the weather conditions, images may not be that good, or not clear cut images obtained by this optical photography which we use our everyday photography. So this type of photographs are not taken using this radiations which are called as visible radiations, but this infrared radiations and this type of waves which are used there in the from the part of this electromagnetic spectrum. These pictures undertaken by this that remote sensing environment, remote sensing, that is IRS satellite. The cameras which are installed on these devices, they have this type of devices, that is radar, as well as the source of this radiation, and therefore whenever such type of images are obtained by the radars which are fixed on this type of the satellites, then it is possible to take a very clear cut and good images with all geographical features. Nowadays it is possible to read using satellite. We can read the number plate of the car which is moving on the road. Now this much accuracy is possible with the help of radars nowadays. Visible spectrum is not that useful, and therefore such type of devices which are using the techniques which are not the visible spectroscopic techniques are not used, but this type of radar techniques are used for photographing this remote sensing and like that. Then number 6 is law enforcement. Again, at local level, police use this type of devices, where if there is some mob or some type of some untoward incident is happening, so to identify that, that means if there happens somewhere a road accident in a remote area, now it may be very difficult for a people to reach in that area within very short time. So identifying, that means taking satellite images of this type of this particular area, we can very easily identify the location where such type of accident or landslide or anything has happened, and a proper help to such type of survivors or that type of people can be provided with the agencies, and that type of law enforcement is also there. Then there is land use pattern. So 7th, that is land use, forestry and agriculture. So large applications are there. Again, all these things are done with the help of the satellites. So land use pattern, that means now government is not needed to go anywhere, government authorities are not needed to go anywhere to take the survey of the how much crops are there in this particular, in the western Maharashtra, how much hectares of sugarcane has been produced. Now no one is needed to go into the farm and measure the areas, etc. Just by taking such type of photographs, special photographs, we can very easily identify how much crop of this particular sugarcane crop has been being cultivated in a particular region. So this type of data can be collected very easily. At the same time, forestation, deforestation, where a cutting of trees is going on, etc., where this forest has been reducing, how forests are increasing, this data in forestry also can be taken with the help of this type of radars, which are again used by the satellites and like that. Other than that, there are several other applications in geology, the science of the geology. Then archaeologists also use this type of techniques or radar techniques to locate such type of locations and identify things and like that. Apart from that, as I said, there can be several other applications, but it is not possible for all of us to identify all to understand all the applications given here. Apart from that, as I said, you can go for the Wikipedia, you can go for any other websites, standard websites, and get the number of applications of the radars. There are several YouTubes too available. Watch some of the YouTubes, that will also give you a correct information on different types of the radar systems, their applications and advantages, disadvantages, and etc. So this is what third device we have learned in detail. Now let's go for the fourth one. That is the, I think this is third one. Okay, radar. So we are doing third, microwave oven, then radar, and now third we are going to look here is number third, that is pyroelectric thermometers. PYRO electric thermometers, or the thermometer which we are using nowadays because of the COVID, that is called as thermal scanner. This is also a pyroelectric thermometer. Material used maybe they are different. Actually it is using infrared, but it is not necessary every time that infrared should be used. Other types of radiations, because in physics we might have heard about something about this black body radiation. The color of the object or the wavelength of an object which is light, it is emitting the light, are the radiations. So wavelength emitted and temperature has a clear-cut relation. So the techniques which are using the radiations emitted by an object to identify the temperature of the body, such devices are called as pyroelectric thermometer. Now there are hundreds of types of pyroelectric thermometers, different types of materials are used, and one of such video, as I said, I am going to show you here. Okay, so anyone just please me tell whether you are able to see this video or not. बघा तुम्हाला व्हिडिओ दिसते का मला सांगा, म्हणजे आपल्याला थोडंसं त्याच्यामध्ये we will understand what these particular pyroelectric devices are. Just tell me, are you able to look? दिसतंय का?
Yes, sir.
Yes, pyroelectric infrared sensor.
As the IoT market continuously grows, sensors are taking greater importance and play a key makes it ideal.
काय होत आहे?
सर लिंक जॉईन होत नाही, असं ग्रुपवर मेसेज पडतात मुलांचे.
आय हॅव नॉट डन एनिथिंग. मी तर काहीच केलेलं नाही आहे. म्हणजे माझं लेक्चर चालू आहे तरी मी प्रयत्न करतो पुन्हा एकदा. काय आहे, कधीतरी नवीन येतात जे मुलं, त्यांचा प्रॉब्लेम होतो. जे दररोज असतात त्यांच्या लिस्टमध्ये नाव असतात, दे आर व्हेरी इझी, त्यांच्यासाठी जॉईन होणं खूप सोपं आहे. अचानक कधीतरी मध्येच 8 दिवसांनी एखादा मुलगा येतो तर त्याला हा प्रॉब्लेम येतो. नाव आय हॅव कनेक्टेड एव्हरीथिंग, मी सगळ्यांना जॉईन केलेलं आहे. ओके, सो आय थिंक देर आर 16 स्टुडंट्स आर देअर on the list. Okay, let's go to further. आता थांबवू नका because these things takes a lot of time. आपलं टायमिंग हे 10:50 ते 11:40 पर्यंत आहे. 50 minutes lecture is there. Now let's see this video. Watch this video. This is what called as pyroelectric sensors.
As the IoT market continuously grows, sensors are taking greater importance and play a key role in these devices. The Pyro Sensor, short for Pyroelectric Infrared Sensor, is a movement sensor detecting human presence. Its primary function induces great energy saving in household equipment, home appliances, or office automation equipment. But not only that, it simply makes life easier. Another common proximity sensing solution is the infrared ray sensor, which works differently than our pyro sensor. Ordinary infrared ray sensors emit infrared light and react to the reflection of objects. It keeps reacting as long as the objects or people are in the infrared light. On the other hand, Comet's pyro sensor detects humans because its piezoelectric ceramic absorb the infrared rays emitted from the human body and can thus detect the infrared signature naturally emitted by humans. So here the detection works on a wider area and is not restricted to a raised path. Another main feature of Comet's pyro sensor is that it can detect infrared rays without using lenses, which are essential for other infrared sensors. Other ordinary pyro sensors need protruding lenses. The projection housing distorts the design of the device. Due to the absence of a lens, Comet's pyro sensor is low profile. It does not protrude, which makes it ideal for demanding visual requirements. For ordinary pyro sensors, it is not possible to detect humans through glass or plastic. With our proprietary piezoelectric ceramic material and element structure of the Chemet's Pyro Sensor, it can detect humans through glass. This gives even more freedom in the design of the outer appearance of the device. And to continue with the features of this sensor, reflow capable SMD configuration, wide view angle up to ±60 degrees, low power consumption down in the microampere range, excellent radio wave performance in high frequency band, compact and low profile. We supply fully modular solutions that incorporate the sensor and the microcontroller as well as the sensor itself, and a type with flat lens which enables longer distance detection. Here are some visualizations of our different possibilities depending on the modules used. The standard configuration detects the middle range up to 2 meters. The high sensitivity model for short distance, but which can detect through glass or resin. And finally, the long distance model, incorporating a flat lens reaching out up to 5 meters. Having a non-obtrusive motion sensor will increasingly become the norm in many applications, in home equipment, home appliances, or office automation equipment. Chemet's Pyro Sensor constitutes the ideal detection support for aesthetic solutions.
Okay, let's move to our notes again. Okay, now let's go to
Hey there guys, Paul here from the Engineering Mindset.
So this is what we are needed to understand what this type of thermometers are, pyroelectric thermometer. So nowadays as we learn about this IoT, Internet of Things, IoT, okay, Internet of Things, here we can have such type of sensors which can detect very directly, very simply, the movements either of animal or person or whatever. So this type of devices, for example, as we say, there is a commode. So whenever a person approaches that commode automatically opens up. So what happens, there are different types of sensors are used, and these sensors are the pyroelectric sensors. Now using these sensors, as I said, we can prepare such type of thermometer which measures temperature of an object very directly without touching that object. And here this is what the principle what we just now discussed, that the radiations which are emitted by that object, particular object, these radiations have a characteristic temperature. Depending upon the different temperature, different types of radiations are emitted, and thereby it is very easy to identify the temperature of an object provided we understand what is the radiation emitted by that particular object. So this particular very simple technique is used in all such devices which are called as pyroelectric thermometer. As I said in the previous lecture, without touching the sun or going close to the sun, it is very easy to identify temperature of the sun using such type of high calibrated devices. So such type of devices are called as pyroelectric thermometer. Or nowadays, as I said, because of this COVID situation, we are using these thermal scanners. So at a distance of 1 feet or few inches, without touching a person, we can identify or we can get the temperature of a person, and this is possible because of this type of infrared thermometers or pyroelectric thermometers. Now in this case, as I said, we are just going to look into physics of that. So what is the physics of that? What are the different techniques that are used? And there is a wide range of different types of ceramic pyroelectric thermometers. Now we are not interested in all such details of that sensors, because day by day the sensors are becoming making available of different sorts, different types, more accuracy, and therefore we are not interested in actual ceramic type of sensors which are used there. We are more interested in what is the physics used behind this, what is the principles used there, what are the different types of materials used there, their characteristic properties, etc. That will be a part of another different subject. We won't go into details of that. So let's come to this pyroelectric thermometer, how it works and like that. So before that, Let's go for its principle. Physics principle of this. Let's write in brief, then we will understand what actually happens or what is the physical principle that is used in pyroelectric thermometer. Also we have to draw certain diagrams, but that will be done later on. Okay, so let's write in brief. The amount of thermal energy, or heat leaving a body by radiation, and wavelength of that radiation, are functions of temperature of the body. Okay, in an object, its temperature and the radiation emitted by that object, there is a clear cut, as well as same amount of energy in the form of radiation that is leaving that object's its wavelength and temperature. They have clear cut relations. That is what you might have studied under this black body radiations. So now this effect has been very nicely used in this principle. So this dependence on temperature, dependent on temperature of the characteristics of radiation, dependence on temperature of the characteristics of radiation is used as the basis of temperature measurement, of these instruments. Okay, and nowadays, as I said, ceramic. I'll talk about something about this. Ceramic sensors are widely used in pyrometers. What is this ceramic? Can anyone tell me what is ceramic? What do you mean by ceramics? Can anyone tell me? कोणाला सांगता येईल का? There are lot many students are there. Can anyone tell me ceramics? अजय सातपुते, संचिता मोहिते, आविष्कार, स्वप्नील, भारती शिंदे. तुम्हाला ऐकू येते का नाही ते तरी सांगा. उत्तर नाही सांगितलं हरकत नाही. What do you mean by ceramic? That is what I am saying. Yes किंवा no काहीतरी म्हणा ना. How I can understand? मला कसं कळणार? So ceramics are the materials which are compounds of metals and non-metals. Chemical compounds, of course, they are not mixtures. So compounds of metals and non-metals, these are called as ceramics. These are very special material having very different types of properties. Thermal properties are too different, its optical properties are different, chemical properties are different, and as compared to other metals, other compounds, so other general compounds, these ceramic compounds have a very, very special property, and one of this property that is used in this case of the this particular. So now what happens if the temperature of ceramic material ceramic material is raised, there is one temperature called as Curie temperature, we are writing definition of that, is raised above some level, the molecules of materials start to move freely, okay, and this is because of these electric dipoles. So whenever temperature is increased to a certain extent, the electric dipoles or the molecules, so actually ceramics are the materials which are having clear cut positive and negative center, charge center. So this is a dipole, or that is also called as dielectric, dipole or dielectric materials. Now these molecules, whenever there is a very low temperature or ambient temperature or temperature less than that temperature called as Curie temperature, the directions of dipoles are random, and therefore total electric charge over that dielectric or that material is simply zero. But whenever temperature is increased, now these dipoles try to align in a particular direction, giving rise to a certain electric field inside this material, and that is called as pyroelectricity. We are going to write this as well. Okay, characteristic try to move freely, rotate freely. The temperature at which this process starts, the temperature at which this process start to happen is called, okay, remember this definition, it may be asked in short answer questions. Start to happen is called the Curie temperature, CURI, Curie temperature. Therefore in the sensors are used in the following way. You have to draw this diagram, simple diagrams are there. Now there are two electrodes, one electrode is here, this is one electrode or plate, electric plate is there, this is the second electrode, and in between this dielectric material is placed, second electrode, this is like a capacitor, so this is a capacitor, and in between this dielectric material is placed. So that means at ambient temperature or the normal temperature, room temperature, what happens, all these dipoles have all different directions, positive, negative, negative, positive, positive, negative, and like that. Okay, positive, negative, and this was. So this is what I can draw this diagram. This is positive, negative, then negative, positive. Sometimes this has positive, then negative. This is positive, this is negative. So all these molecules I have shown here, they have different random directions. So this is negative, this is positive, and like that. So this is what a random directions. Dipoles at a random direction. At ambient temperature, or the temperature is very low temperature or room temperature. If I connect here positive, there is some electrodes here, there won't be any potential. This point is connected here, there won't be any potential here. But whenever the same object, if it is kept or this temperature is increased because of this radiation, now you will find the picture is different there. So at high temperature or this beyond Curie temperature, what will happen? All these molecules there in this dipole, they start aligning in a particular direction. So this is positive, negative, again positive, negative, positive, negative. So positive, negative, like this. You can draw several such molecules which have a very specified directions, positive, negative, and like that. And therefore whenever it is connected to certain voltmeter, you will find that there is some potential. Okay, and actually there is a charges. These charges are generated on these two electrodes as shown here. So this is positive and now this is negative, and this gives rise to a electric field as shown here. And the amount of electric field here, that is the property of the temperature. If temperature is increased, these dipoles align more and more. The charge centers, positive charge center and negative charge centers, get separated more and more electricity generated, and that is called as the pyroelectricity. Okay, so at higher temperature, electricity is generated. Okay, and this is called as pyroelectricity. This phenomenon is called as pyroelectricity, okay, which is a characteristics of the temperature. If temperature is increased to above a Curie temperature, then this particular process of aligning this positive and negative charges starts, and once this process starts, certain electric field is generated. This electric field is now a characteristics or the measurement of the temperature of from where whatever we are getting this radiation. So you have to just direct this particular sensor toward that particular object. Depending upon the radiations emitted by that object, these molecules gets realigned in such a manner it produces a certain electric field across these two electrodes, and therefore it is possible to measure the temperature just by measuring this electric field. Now there are several different types of devices, several different types of sensors are there, parameters are there, and one of those two parameters we are going to write here in the following case. Okay, so we'll write here the polarization. The polarization occurs is a function of temperature of the object. Polarization that occurs is the function of the temperature. Okay, and this is called as primary pyroelectricity, etc. All these definitions are given there. You can read all these particular things in the book. Okay, then there is one relation we are supposed to write here: the dipole moment. Dipole moment, capital M, of the pyroelectric sensor. Pyroelectric sensor is given by capital M is equal to mu into capital A into H, where the small mu is dipole moment per unit volume. Moment per unit volume. Then this capital A is sensor's area, and H is its thickness. Now depending upon, as in the video we have seen, there is one company, that is Chemtech, and that has provided this type of pyroelectric sensors. And now depending upon different company, brand and technique, etc., there can be several different types of relations between this temperature and this amount of electricity generated by these pyrometers and so on. So we are not going to go into details of all that. So such type of relations you can look into the textbook if you want some more information there. But the devices which are using this principle of physics, that the pyroelectricity generated because of the radiations, and radiation is the characteristic of the temperature. Therefore this type of devices are nowadays very popular for measurement of temperature, and that is what an advantage I have just talked several times, that this type of devices are not needed to touch to the object of which we are supposed to take the temperature. So that's what the thermal scanner nowadays we use. That is a simple device which is using this type of concept or the physical concept for measurement of the temperature and so on. Okay, in our textbook a separate 2-page information has been given on different types of pyroelectric sensors, but from my point of view it is not needed at this stage to read all these things. If you are interested, you can go for that. On Wikipedia also we can get a lot of information related to these pyroelectric sensors, ceramic sensors, their other properties, electrical properties, and so many things. But I think though you can skip this part. Just try to understand what is the pyroelectric thermometer and what is the principle basically used in that particular case. Okay, and now let's go for final thing, that is application. So applications. So first application is, as I said, motion sensors. Motion sensors used for security purpose. Then second important application we can go here, medical infrared thermometers. Infrared thermometers, that is second application. Third is measuring temperatures of extremely hot bodies or moving objects. It is possible with the help of this type of thermometers. And fourth application we can go here, actually there are, but there is no need. So these three important applications are there. So nowadays you might have seen there are several different types of security systems. As I said in the beginning, that is IoT, Internet of Things. Now there are several different types of sensors which directly, that is this type, one of such an example I can give. Nowadays we are using traditional switches. That means once the switch is made on, it will remain in on position unless and until it is made off by a person again. In spite of that, in my house there are 4 or 5 different rooms, and a person, there is only one person who is living in that particular house. If he uses each and every bulb, and then the electricity bill will be very large because large consumption. So if I have such an mechanism that whenever I am present in that room, this particular bulb or that particular tube light will become on, and as long as I move out of that room, after 10 seconds it will automatically go off. Now in that case, how to operate this? That means to make these particular things happen or possible, we use this type of devices which are called as Internet of Things. This is not only, other than that there can be several other aspects can be covered under this Internet of Things. So if anyone is interested, you can just go for the search of this, what is the technology of this Internet of Things and how this technology is nowadays is being used everywhere, in theaters, in malls, in hospitals, in vehicles, in schools and colleges, and everywhere this Internet of Things is coming with a very high speed. And this is what the devices, or this is what the techniques that we are using here in pyroelectric thermometers. Same techniques are used there. Now these are cameras which are very sensitive to infrared radiations. These cameras are deployed at different locations, and they identify, these cameras identify the movement of the objects, animals or humans or anything like that, and thereby the on-off situation or on-off control of that system is possible. And this is what called as Internet of Things. So this technology is coming up with a very, very high pace, high speed, and these particular techniques are being used there as a ceramic control, sensors and like this. Okay, actually this is not written in our book, but this is what a physical application of this technology, that is what we are learning here. So we have finished these 3 different types of aspects here. Now in the next lecture we are going to see next particular thing, that is the X-ray photography, or you might have seen in hospitals somewhere sometimes there is some fracture to a person, either his bones are fractured. Now if that person is taken to a hospital, and in that case we go for X-ray scanning or X-ray photography. So what this particular technique is, not in technical sense, but what is the physics behind this type of X-ray applications, that important application we are going to cover here in tomorrow's lecture. At the same time, we are going to discuss few things about this X-ray crystallography. So simple cubic, then face center cubic, body center cubic, these type of different crystals are possible for different types of compounds, and how to go for study of this crystal structure using this X-ray spectroscope or X-ray radiography. This is what the point of discussion that we are going to discuss tomorrow. Okay, so today we will stop here. Before that, I have to take attendance for all of you. Okay, just a minute, don't go anywhere. Let me do this.